Our probe is also connected. Align the red dot with this red dot. Just insert it into the red dot. Then, what needs to be noted is that into receiving and sure to connect the receiver then here. Connect the transmitting line. Connect to this launch port. First of all, we need to this side of the wall and the other side. This kind of line point has been laid. Generally, the spacing of the course is a grid of 20 cm. We are laying a grid of 10 centimeters. After laying at every point, squeeze a little butter as the lotus root. You don't need to squeeze too much butter. Just a little bit. Also on the other side of the wall, this point. Then we click on each point. Squeeze a little butter. Then we click this ultrasound test in compactness and cavity detection. After entering, let's click on the parameters. Then create a new project. Just name it and name it whatever you want. Then create a new component. Then next we enter the number of rows and columns. For example, if we are 4 rows and 5 columns. If we were laying out spots, if it's another footwork, we can enter other numbers. Then this piece of input, the short answer is how thick is this wall? Our wall is 300 m. After entering, you can enter our standards. Select the standard that suits us. After all the inputs, we can enter the sampling parameters. Simply speaking, he'll enter one of his sample intervals. The smaller the sampling interval you lose. The smaller the sampling interval is, the sparser the waveform is. The larger you input, the denser the waveform. Let's take 0.8 then as the sampling example. We just need to enter 1024. Then this is the transmitting voltage is selected according to the penetration distance. This is 300 centimeters. We can use 250. If the penetration distance or the size of the component is relatively large, we can adjust the transmitting voltage accordingly. Then receive the channel. We plug in a channel. You can choose one channel for this one. Then 0 to 10. Transducer surface. Apply a small amount of butter lubricant. Or if there is no butter, we can use toothpaste instead. Then align the two probes. Press and hold. Then we can choose to adjust 0 here. Click to adjust 0. Click to adjust line. At this time, it switches to our sampling interface. Let's adjust the position of the first wave. Adjust the size of the first wave. And then it stops at 0 sound. 2 milliseconds. This is successfully adjusted to 0. And here, you can also use quotations or non-referenced, unquoted words. We can enter our experience value here. For example, value. I think the speed of sound I can just enter it in the critical value of speed of sound. If you choose to use the citation method to the specification, and based on the specification and your measured data, to calculate the critical value. If it's a non-referenced method like this, we need to enter it manually. We can enter the value we think is the critical value. Let's take the citation method as an example. After all settings are completed, click OK. Click OK, and then at this time, we place the probe on both sides of the component and compact it. Then the other side of the component is also at this point. Then we can collect data. After this data collection is completed, on both sides, move to the next point at the same time, and then move to the next point simultaneously. When we place the probe, after placing the probe on the wall, Then we click Sampling. Click Sample. Then we find the adjustment. Use one finger to move left and right. It's the position of the waveform before and when after. Moving up and down. This is the magnification and stretching ratio of the waveform. Adjust its gain. We adjust it to make the left side of the waveform about 7/e of the entire screen. Then let this amplitude of this first wave about 1/2 of the lower half of the screen. That's it. When the waveform is stable, we click on the storage. This is the first measurement point. What is its distance? What was that sound? And the sound velocity. This point has been measured. After that, let's move the probe to the second point at the same time. Move to the second point. Move to the second point. After it stabilizes, we click on storage. This is the second acoustic measurement point. At this time, which has been measured. The third measurement point at the same time. And store it, and so on. Then we measure the entire component. After collecting the last measurement, the entire component has been tested. That's it. At this time, we can go to the menu bar to export the data. And here, it's our defect diagram. After all tests are completed, what does the red square represent? The red square represents abnormal sound velocity, which means the first side point in the first row is the speed. And what does the red circle represent? It represents the sound velocity, which represents amplitude anomaly. Because there are no amplitude anomaly points, it will be marked with a circle on this measurement point, indicating that this point is amplitude anomaly. Square and circle, it represents the second critical value anomaly, which means it means the first critical value.